get through all the print statements? Did we get to, so we were at print statements, all right. And we started expressions, all right. So we will do expressions, escape keys. So we won't do escape keys. I think we got enough of the escape keys. And we'll do print a little bit. So print is whatever you pass in, it'll print it, just like this. Then remember, everything inside of quotation will be printed. So if you have two quotations, they will be printed 2 times. I'm sorry, separately. So if I run it, I'll get test and test 2 with a space, even though there is no space in the middle. And remember, everything inside of quotation will be printed. And it doesn't matter how long the string is, it'll print it. So the green squiggly, so this is a green squiggly line. So green means there's a formatting issue, not formatting issue, grammar issue. So every time you have a comma, you have to have a space after it. So if you don't have a space, it'll tell you, well, it doesn't look good. You need to fix it. So if I put a space there, and yeah, you can ignore it. In the future, you shouldn't. You should format your code to look pretty. But yeah, for right now, you can ignore the green ones. And the question I had yesterday was there are 2 ways of writing strings. You can have single quotes or double quotes, and they both work the same way in Python. In Java, they work completely different ways. But in Python, if it's a string, you can have single quotes or double quotes. So yeah, so print is pretty easy. I'm gonna go get rid of that. So then we have variables. Remember, we went over variables. We have x equals to 5, y equals to 10, and then we have z equals to 15. If we wanted to print x, we can just print it like this. We can have a print function and we pass in the variable. And if I run this now, what would print? Yep, so nothing would print. But in the background, what happens is it creates memory for these variables. So what happens is, remember, these are pointers pointing to a memory location, and the memory location value is 5. So in this case, what it's going to do is going to have an x pointing to a place in memory. So that place could be anywhere in that memory. Since we're just running this program, we're not storing any values to database. So this would be memory in RAM memory. So x would make a space and to store 5, and program will make a space and call that space y, and the value of that space would be 10. So every time we're trying to access x like this, it's going to go into that memory. It's going to say, well, where's x pointing to? It's pointing to a memory location. Let's go get that value. So it's going to go in and get 5 from there. So if I run this now, what would print? Remember, always disturb me, always cut me off, ask questions as much as possible. Because if I'm teaching, I'm just going to keep going, and I'm just assuming that you guys are understanding, because I'm not able to see your faces. So I'm going to assume you're understanding unless you ask me questions. All right. So and then we have x equals to 11, and if I print this now, what would happen? So 11 would be printed. Why is 11 printing? Yeah, so that last thing that I can store in the computer, it overrides the value. That is correct. So now remember, this is just a variable name. That's memory location. That's pointing to a memory location. I can update that value anytime. So the way you update it is just x equals 2. You just override that value. So on line 4, I'm just overriding line 1. So I'm just overriding the value of 5. So if I do something like this, what would be printed now? So why is it printing 16 now, and why was it printing 11 before? So a little hard question. So what the compiler is doing is it's not actually assigning the value. The last thing it does is assign the value to that memory location. it actually calculates the value first. So first thing it does is it reads this right there, X, and it says, what's the value of X? It goes back into memory and gets that value 5, and then add 11 to it, which is 16, and then stores that 16 into X, then stores that 16 into the location of where the 5 was. So the last thing it does is stores the value. First thing it does is does the calculation. Okay. So if I run this, I get 16. Let's say you have, all right, so let's do a different example. So let's say you have Green River, 20 students. Highline has 18. And then we have Tacoma has 16. And then we have Bellevue College has 15. So now, if I wanted to know how many students does Green River has, how would I get that? Green River, exactly. So if I do this, it'll give me Green River has 20 students. Right. So now let's say Highline lost, and now if I print Highline, what would it print now? All right, and Tacoma lost 2 students. Well, not 2. Let's do 5. And if I print Tacoma, what would print? I get -5. Exactly. So I didn't. So here, what I'm doing is Highline lost 2 students. What I'm doing is taking the value of Highline and doing a -2 from it, and then assigning that value back to Highline. Exactly. So in here, I just did -5. That means Tacoma. I'm overriding the value of Tacoma to -5. So now, if I do something like this, now I'm 5 students left Tacoma. I can subtract it from Tacoma and store it back into Tacoma. So if I run it now I get 11. And let's do, so if you want to take average of all, let's say Washington State wanted to take an average of all the colleges they have, and they only have 4 colleges in Washington State. How do you take the average of all these colleges? How many students are there? So if people coming from math, how do you actually take average? Add them and divide by how many there are. So in this case, 4. So average, so it's going to be, I'm going to create a new variable, average, and then it's going to be Green River plus Highline plus Tacoma plus, yes. So that's where the PEMDAS or order of operations comes in. So if you know what order of operations are, that are, oops. So for short, it's called PAMDS, like this. So it's parentheses. Then we have exponent. I'm pretty sure I have spelled it incorrect. Yeah, I probably spelled it. I think there's an E here. All right, then we have multiplication, division, and then we have addition and subtraction. So I know that it says multiplication division, but they're actually on the same level, and addition subtraction is on the same level. So you do parentheses first, then exponent, and then multiplication division. So in this case, the first thing in this math you would do is division. And if you're dividing this first, you're actually not getting the value you actually want. So if you run this now, you're getting 57.75. And by looking at the values, we know that's incorrect. So to get the average, what you can do is just use parentheses like this. And then that would give you the right answer. right? So now we're getting an average of 17.25. And in reality, obviously, you guys know that you can't have 17.25 students. So how can we fix that? I think we went over that a little bit last week. Um, how do we get whole number out of the average? What can we change in this equation so we get the whole number and the actual whole number, so we know that many students is the average? Round it, we can round it, or remember value mod. So in programming, or at least in Python, they have floor division. Remember, if you have two backslashes, that means you have floor division. All right, so if we don't remember that, we'll go over that in a minute. So floor division, what it does is it gives you a whole number. So you divide it's division, but it always gives you the floor of that value, whatever it is. So in this case, it's 17.25. It's going to cut off 0.25 at the end. It's going to give you the floor of that value. You're still dividing it, but you're getting the floor. So run it. We have, move to the bottom. So we have, this is multiplication. This is division. And this is addition. And this is floor division. And this, like I said, floor division has two division signs, and you actually get the floor of that value. So you have 2 divided by 2, 3 divided by 2, what would print? This right here. Okay, so it looks like we weren't able to get to floor division last week, so we'll do that here. So if you print 3 divided by 2, what would print? 1.5. So if I run it, I get 1.5. But I do floor division, what would I get now? Remember, floor division only gives you whole number, and they give you the floor of that value. So it gives you the floor of 1.5. So does everybody know what floor and ceilings are in math? So see, ceilings are you get the top, round up, and floor is you round down. So in this case, you should get 1. You have 13 divided by 2, or 6.5. And if you do floor division, you get, and then you have 45 divided by 2, you get 22.5, and do floor division. It only rounds down. It doesn't, even if you have 0.9. So let's try to come up with a value. You get 0.9, divide by 4. Yes, it only rounds down. It does not round up. So even if you have like 6.9 or something like that, I will give you 6 only. So all it does is it takes out all the decimal values afterwards. So you have 45 divided by 7. I'm going to do floor division, and it only gives. How do you round up in division? Or yeah, so they're built-in functions. You can use ceiling function and stuff like that, but this is only to get whole numbers. You don't actually have like a ceiling division or anything like that. You need to use functions like print. Well, print as a function, so similar functions you have built in. We'll go over that later in the course, how to use functions. But in this case, this is just floor division. We don't have ceiling division. So there are ways to get ceiling out of any number that you pass in. So you'll be using those functions if you need accurate math like ceiling or floor, that kind of stuff. But this is only floor division. So the example I gave you was, so you're taking the average of the students. Obviously, you only want whole numbers because they're students. So that in this case, you would use floor division. But there are some cases you want to use ceiling division, and it depends on what kind of math you're doing. Or I'm sorry, not ceiling division. There's no such thing as ceiling divisions. I'm sorry. But a division, and you take the ceiling of that. So there's another symbol, and that is modulus. Right? Modulus. So what is a modulus? What does has anybody worked with modulus before? Did we go over modulus last week, or did we get a chance to go over modulus? The remainder. So do modulus. I'm gonna actually open up a pen and show you guys. So 5 divided by 2. Now, if you do 5 divided by 2, you get 2.5. But if you do modulus, 5 mod 4, I'm sorry, 5 mod 2, you get 1. So the way you get 1 is you're doing, so going back to simple math, you're doing 5 divided by 2. How many times does 2 goes into 5? 2 times. So you write 2 up here. And what is that value? 4. And the remainder is 1. So this is what it's looking for right there, that value. So when you do mod, mod actually gives you the remainder. So if I don't even know if they teach this in math anymore or not, but so when is it relevant in the real world? It would be relevant to find an even or odd number, and that is the best way to do it. One of the best ways. So let me actually show you more example of modulus, and then I'll show you how to use it for even or odd. I'm going to delete this. All right, so now let's do a different number. So you have 10 mod 2. 10 mod 2, how would you do this in your head or on paper? You have 10 divided by 2. How many times 10 goes into, I'm sorry, 2 goes into 10? 5 times. So you write 5 up here, and then what is that value? And 2 times 5 is 10. What is the remainder? 0. So now, if I print this, if I run this, I will get 0 because that is the value, that is the remainder. A little harder one. So you have 15 mod 4. If I do this, what would print? If I run it, what would print? 3. So the reason it would print 3 is you're doing 15 divided by 4. How many times 4 goes into 15? So you have 4, 8, and then 12. Then if you do add one more time, it's 16, so you don't want that. It goes into 15 3 times, and 4 times 3 is 12. And what's the remainder? 15 minus 12 is 3. So this is the remainder. We always take the remainder. It's not this 3. It's not this 3. It's this 3 right here. So the more practice you do, the better it'll be for you. And so instead of getting a decimal, you take the remainder as modulus. Yes, Josh. Yeah, that is correct. So when you divide it, you don't actually get the decimal. You just take the remainder. All right, so now using this in the real world, the best way I've used it, I've seen other people use it too. There are multiple ways you want to use this. Just depends what kind of math you're trying to do. It's figuring out if a number is, you have value equals to 15, and you want to figure out if it's odd or even or odd. So the way odd or even or odd, even, yeah. So now what you want to do is value mod. Every time you want to figure out odd or even, you want to mod by 2. If odd or even this variable is 1, that means you have an odd value. If it's 0, that means you have an even value. So every time you do this, so if you run it, you get 1 because 15 is odd. Change that to 14 and run it, I get 0. And doesn't matter which value you change it to, only thing it's checking is odd or even, and it gives you 1 or 0. So you have 101, what would print now? 1, because 101 is odd. If I change this to 150, what would print? 0, because 150 is even. So the reason it's doing it, it works for every single, yeah, so let's go over that. So it works for every single number, and you mod that by 2. How many times 2 goes into 10? 5 times. 2 times 5 is 10, and then remainder is 0. So this is what it's returning you. Every time you have an even number and you dividing that, you mod that by 2, you get 0 because there's never a remainder every time you do it by 2. So let's change this odd number and you mod that by 2. How many times 2 goes into 9? Goes into 4.5 times, but we take 4, and which is 8, and remainder is 1. Why is it 1? Because 9 is an odd number. Every time you try and figure out odd or even, you mod that number by 2 and see if it's returning 1 or 0. Yeah, it doesn't matter what number it is. Let's say you have 19 here and you're doing, let's erase everything else. And 2 goes into 19 how many times? 9 times. And 2 times 19 is 18. And remainder is 1. Why is it 1? Because it's an odd number. So I have almost every project I've done for Boeing, there's a lot of math involved, a lot of math involved because their max speed, their temperature control. So I'm working with math all the time in my projects. And I'm always using modulus, I'm always using floor division, I'm always using all these values, but modulus comes in handy when you're trying to figure out the value that's coming in. You want to check if it's odd or even, and that's one of the best ways to do that. Average, floor division, let's take this out. So we did this division. The next thing I want to do, we have all these, we've covered it. So you guys know what subtraction, addition, division, multiplication are. They work the exact same way they work in math. I think went a little bit over that already. Then in programming, we have or statement. So, oh, I'm sorry, before we even get to that, I'm going to move this to down, I'm sorry. So I want to go over data types in Python. So in Python, we have the string. We went over string. We have integer, or short for int. And here short is str. And we have float as the other data type. Float is basically a decimal value. So we have x equals 2. This is a string. Then we have y equals to 5. And then we have z equals to 10.56. So now x, this is a string, y is an integer, and z is a float. Float is just a fancy way of saying it's a decimal value. It's not going to be a whole number. So even if it's you define, well, you can define variables in Python. So in this one, it's going to be, so if so I'm trying to differentiate from Java. So in Java, what happens is if you're coming from Java, you would have to declare a variable. Once you have declared a variable, that data type, you cannot change that data type. In Python, you can change the data type any way you want. So we'll do an example of that. So let's say there's you wanted to see which data type X is. There's a function you can use, type, and pass an X, just like this. And if you run it, it actually tells you which data type X you have. The class, which class it is, it's a string class. str, remember, stands for string. And if you wanted to know which data type Y is, you just type in through that function, type, and run it, and it gives you integer. And same thing with Z. So even float, if you have 10.0, this would still be a float because we have point something afterwards. If I change this to just 10, then it's an integer class. But if you have 0.0, even though it's a whole number, not you don't have any decimals afterwards, but you wrote it as a float, which is 0.0, it's going to go towards that float class. So in the background, what's happening is it's defining these, and it's storing a certain amount of memory for that location. Integer has a maximum value you can store. float even has a bigger value. So every time you store float, declare float like this, it reserves that a lot of memory in there. And in Python, you can change the memory up and down depending on keep declaring more, changing the variable. And in Java, you cannot. So there's a maximum limit of integer, the biggest number you can store in an integer. And you have float, you have decimal, you have long. There's a bunch of different data types in Java. But here, main things you have to worry about is string, integer, float. And one more thing that we're going to work on in a little bit. Any questions, any concerns so far? Remember, all these things will make more sense to you after you practice it. So if you're just relying on me explaining it here and you just looking at it, you don't even have PyCharm open, you're not practicing, as you're not typing it as we were learning it, it may go over your head, especially if you're a beginner. So I would highly recommend going home. I'm recording this, going home, watching this, and try to do it on your own on PyCharm, and it'll make more sense. All right, so now if I run it, X is a string. So in Python, good thing about Python, what you can do is you can change the variable, override it from string to an integer, just like this. And now it changes to a string. To integer. Before X was a string, I did X equals 5. Now X type is an integer. So you lost me here. So where did you lose me? So here, you got to this far, we're checking the type of X. X is a string. So now in Python, what you can do is you can update a value. You can't do that in any other language. Any other language that I have worked on. You can't just override a data type. So remember, this is the data type for this right here is string. By doing this in line 10, I'm overriding the data type to an integer. Now it's using class called integer and storing a number. This is not a string anymore. And the next line, if I actually just print X, I get 5. Yes. So if I don't have this, I'm guessing that's what you're asking. If you don't have this and you print X, you print the string just like this. But if you override it just like this, then it changes the data type and the value. And you can do that with, let's do with y equals 2, 5.0. So print, I'm sorry, not 5, y right there. And if I run it, before it was an integer, now it's a float. And when you print float, you get 5.0. If I take this out, don't have that in there, I didn't change anything. You have integer and you just get 5. But when I override it, it changes the data type, the class, float, and prints 5.0. If you don't have any questions, remember you have to go home and practice, otherwise there's a chance you'll fall behind. So please go home and practice. All right. I'm not going fast, I'm not going too slow, I'm trying to go right in the middle. So if you're advanced, you just have to have some patience. And then if you're falling behind, that means you need to work a little more to catch up with the class. There are different levels of student, and I'm just trying to go at the pace that most of the students will understand. So the other data type we have is Boolean. Has anybody heard of Boolean? Does everybody understand what Boolean is? The Boolean, you can only have 2 values in there. You have true or false. You cannot store any other value in there. You either have true or you either have false. And true represents 1, and in the memory, if you look at the memory, and false represents 0. So if you use C++, you'll always see people using integer instead of Boolean, and just store 1 or 0 to represent 1 and 0 to true for true or false. And I've seen that at work as well. I have used it 1 and 0 instead of using a Boolean. So, but Boolean is there for you to determine if something is true or something is. So what does that mean? And let's say we have X equals true. and y equals, then if you wanted to print it, you can do x like this. And if I run this, what would print? If I run it, I get true. And if I change this to y, I get false, because that's what the value is. That's what I've stored. Remember, this is not a string. So this is a Boolean. The reason it's turning yellow because to differentiate, it's not a string. I'm not actually doing something like this. This would be a string, but this is a Boolean. So how would you actually use it? There are other comparison tools, comparison operators that we're going to be using in Python. So you have um, or. Did we go over or and? Not yet, right? Declared it here, but or and. So or and means when you're comparing two values. Or, so what here I'm asking is y or x. It's going to return every time you use and or, it's going to return true or false because you're trying to compare two things. So it's either, or just means either y is true or x is true. Then this whole statement becomes true. So if I do the result equals, I'm just going to do x or y, and I'm going to print that result like this. So you have x or y. What it's doing is, well, does anybody know what is it going to print now? If I run it, true either or. So it's actually going to print true. So remember, every time you use this expression is going to return true or false. Only two values. Nothing else is going to return. So it's checking if true or y is true. If either one is true, this whole becomes true. So in this case, x is true. So x is true or y is true. Even though y is false, this whole statement becomes true, and that true gets assigned to result, and that's what we print. So if I run it, yeah. So yeah, it's practice will make a lot more sense when you actually do it yourself. That's how I learn it too. I can watch videos, I can watch lectures, but until I get on the computer and start typing it, it just I won't learn. So if you're one of the students, please go home and practice. All right, so now let's go back to this. So what if I have something like this? X is false, Y is false. Now we're comparing. I'm going to put this in parentheses so people understand a little better. So or X or Y, which if either one is true, this whole statement is true. Is either one of them true? Even if you have Y to true, this whole statement will become true. So let's actually, let me draw a table and show you guys. So you have two values. So you have X, then you have Y. So X is true. This is the OR table. Sorry, my handwriting is really bad when I do this. And this Y is false. X is false, Y is true. X is false, Y is false, X is true, Y is true. So this is the result. Well, Josh will get to that in a minute. Let's go over this table and see what you guys are gonna get. So this is the OR table. X is true, Y is true. What would be the result? The result is true. X is false, Y is true. What would be the result? True. Yep. Remember, it's an OR table, so either one has to be true. This whole statement is true. X is false, Y is false. What is this? And X is true, Y is true. What is it? Sorry about my handwriting. I think you're still able to read it, but that's how the OR table. Yes. In Java, the OR is just like that. Yes, Kevin. So the question I think somebody had, where did we go? What makes the system decide what is true or false? We actually decide, we assign the values to the variables. So we tell the system that this X is false or true, or Y is true or false. So when you're writing a program, you'll be the one deciding. Or if you're getting a value from somewhere, from the internet, or when you're doing advanced level programming, from a different program, you're getting some values. They'll be the one deciding what is true or false, and then the only thing you'll be doing is checking. You'll be checking if something is true or false. So let's say you are getting two values, one from Facebook. You're getting a Boolean value from Facebook, and you're getting a Boolean value from Instagram. And then on Twitter, you have to decide if this user has an account on Facebook or Instagram. So that would be Boolean value, true or false, they have an account or not. And then what you'll be checking is you have X would be Instagram or Y would be Facebook. And you're checking either one is true, then that means you have previously used social networking. And just like or, you use and, but and works a little different. So now what would print? I had, instead of or, I have and. So if I run this now, what would be printed? So and means, remember, this is just a question. X is true and Y is true. Is that statement true? So it's asking, is X and Y true? That's what it's asking, statement right here. And what is the answer? So yeah, the answer would be false. So we run it, I get false because both of them are not true. And same thing with if you have or, it would be is X or Y true. And that statement, whatever the result is, it's going to return true or false. Or you can you look at it as yes or no. Yes would be true, no would be false, but it's in this case you're using true or false. Right. So if I change this to false, what would be printed? And remember, the result, the statement has to, the only reason it'll become true if both of them are true. So if I run this now, right, so let's do the table for this. Try to do a little better. I don't know if I can. Okay, so you have X, let's actually use text, and this is the result. This is true. This is false. This is false. This is true. This is true. This is true. And this is false. This is false. And we're working with and. All right. So what would be the result of this column right here? False. What would I get if X is false, Y is true? What would I get here? False. And X is true, Y is true. What would I get? True. And X is false, Y is false. What would I get here? So if you wanted to, I should have done side by side these two tables, or if you wanted to compare them, you can always go in the video. Remember, I am recording this, so you can compare how and or are different. But by a lot of you answering the questions, I think everybody kind of understand what's going on. Well, most of you understand what's going on. Yeah, so or needs one to be true, the whole statement becomes true, and need both of them to be true for the statement to be true. Yes. All right. So now we have or and. Then after we have comparisons. We have a comparison tool. So comparing would be less than. We have greater than. We have less than or equal to. We have greater than or equal to. And we have equals. So this would be just equal to. and we have not equal to. All right, how many of you actually use these anywhere? Hopefully you've used it in math. We'll get rid of this. So let's start by less than. How would you use it? Remember, all these actually return true or false. So remember, you're comparing two values and you're asking the compiler or the program to, is this statement true or not? So let's say you have print. So I'm gonna print the result. So you have 2 and less than 5. So all you're asking the compiler is 2 less than 5. So what is the compiler going to return? Remember, this is a comment, so this is not a code. This is just a comment. I'm typing it in, so people know what is it doing in the background. So it's asking, is 2 less than 5? So it's either going to return true or false. Only two options it has, or an error if you have syntax error, kind of like that kind of thing. But it's only going to return true or false. Yeah. In this case, it returns true. And if you do, oops, greater than, in this case is 2 greater than 5. I run it, we get false, because 2 is not bigger than 5, we get false. All right, so the same thing, you can use less than or equal to. Remember that would print true or false. In this case, it's true. Even if I change this to 5, so 5 is less than or equal to. So this one is checking 5 is less is 5, sorry, 2 less than or equal to 5. So it's asking this question to the compiler, and is 5 less than or equal to 5? What is it going to print now? True, because it's not less than, but it is equal to, but we have or in there. So it's going to print true. Or equal to, that would just print true, because even though it's not greater than, but it is equal to. Then you have equals, and that is you're asking the compiler, is 5 equals to 5? That's what you're asking. There's no or, there's no and. It's asking, is 5 equals to 5? If I run this, it's true. If I change the value, one of the values to 6, and run it, I get false because 5 does not equal. The next thing we have is not equal. So the way you do not is just an exclamation mark. Not equals to 6. The 5 does not equal to 6. And if I change this to 5, that becomes false because they're actually equal. But we're looking for not equal to. So I'm going to delete all of this. I want to go over PIMDES and I'm going to delete everything else. So you have an equation. Let's say you have x equals 2. You have an expression. You have 5 plus 2 divided by 3 minus 2 times 4. In this case, what would happen first? So the first thing you'll do is division. Even though you have multiplication and division on the same level, if you have something like this, you start from the left. So and we have multiplication and division, they have the same precedent. So you start from the left. Left, you have 2 divided by 3 first, so you work on that first. So the first step you would do is 5 plus 2 divided by 3, which is what? What do you do if you do 2 divided by 3? Let's go and change this to 3 divided by simple math. and then 2 times. The next step is, what's the next step? Multiplication, 2 times 4, we have 5 plus 1.5 minus 2 times 4, which is 8. Just like this. Now you have addition and subtraction. Remember, you start from left to right, and the next step would be 5 plus 1.5, which is 6.5 minus 8. And the last thing you do is subtraction, which is 6.5 minus 8 is negative 1.5. So this would be the result. So if I print x, I should get negative 1.5. Remember, all these are comments. I'm just doing it step by step to show you what's going to happen first, what's going to happen afterwards. So in the in-class assignment, this is how you're going to be doing it. So in your in-class assignments is expressions, and you have to figure out what the expression is and what the result is going to be. Don't just type it in Python and get the results. You actually need to show step by step what's going to happen first, what's going to happen next, and what's going to happen last. Yeah, so the thing we want to comment last week, we had 2 ways of commenting. You have multi-line comment.